All right, last section. I'm going to talk about gas forming reactions, and I'm doing this more just to talk about it. It's a double displacement, but I'm not going to ask this question on a test, but you'll see this on MindTap. What I do expect you to do is be able to recognize what is a gas forming reaction. And so in this case, a gas forming reaction, fairly obvious, it forms a gas, whether it's CO2, SO2, or H2, or ammonia. And so in almost every single case, it's a double displacement. And then what happens is one of the products immediately breaks down into a gas. So let's take a look at an example of this. So for example, if we have the following, in an acidic solution, one of these when one of these acids form, they form above products. So for example, if we make H2CO3 or H2SO3, it instantaneously breaks down to CO2 gas or SO2 gas, okay? And so the other thing that can happen is if we have a metal. So notice in this is not a double displacement. This is a single displacement where the potassium is going to kick out the hydrogen, one of the hydrogens. So this is a single displacement forming H2 gas, okay? The same thing over here. The zinc is going to, the positive zinc is going to push out the positive hydrogen to form ZnCl2 and H2 gas. So if you displace hydrogen, you'll form H2, especially in an acidic solution. And then last but not least, you can have, in a basic solution, this is a double displacement, the NH4 reacts with the OH, and the Na will react with the Cl. And what happens is you form NH4OH, which instantly breaks down into NH3 plus H2O liquid. Okay, and so what you would do is you would just basically make sure that if you're in a basic solution, that's going to happen. So once again, I'm going to show some examples, but I'm not going to test you on this, but you'll see some of this on your MindTap. Okay, so write the net ionic equation for the following. When you have hydroiodic acid combining with solid zinc carbonate. So the first thing we end up doing for this is we write the molecular equation, or just write the typical equation. Why I put the 2 there, I'm jumping ahead, is you have HI, aqueous, plus solid zinc 2 carbonate. So that zinc is 2 plus and carbonate is CO3 2 minus. And so what happens is you're told it's solid, but in this double displacement reaction, the H is going to react with the CO3 and the zinc is going to react with the iodine. And once again, I like to break down charges. This is +1, -1, this is +2, this is -2. And so what you're going to, when it's balanced out, you're going to get H2CO3 plus ZnI2. Now, if we scroll back up, keep going up, and we take a look, notice what happens is when you make H2CO3, it breaks down immediately into CO2 and water. So if we come back down here, okay, this is going to break instantaneously down to CO2 gas plus H2O liquid. Okay, so let's write this out and balance. So this is going to be 2HI aqueous plus ZnCO3 solid is going to go into CO2 gas plus H2O liquid plus ZnI2 aqueous. If you take a look you'll see that iodine salts are soluble. And so now that's the overall, and now we're going to break this into the net ionic. So anything that's can be soluble will break down. HI is a strong acid, so 2H plus I minus, AQ. Now the solid doesn't move, CO3 to solid. CO2 is a gas, so we don't break that down. Pure water does not break down either. And then you're left with Zn2 plus 2I minus, aqueous and aqueous. Last step is to remove any spectator. So if we take, we're going to get my color here. We have, notice we have, oops, I made one mistake. I did make a mistake. This should be 2I minus, yes. Now what we're going to do is remove the spectators. You see that you have a 2I minus here and a 2I minus here. You can't do anything with the 2H plus or anything else, so your net ionic is going to be 2H plus aqueous. And so that H plus is going to basically displace the zinc to form our CO2 gas plus H2O liquid plus Zn2 plus aqueous. And so that is the net ionic equation, and that is an example of a gas forming reaction. Once again, if I ask this or a test or a quiz, I would just say, is the following reaction a gas forming reaction? And as long as you see a gas being formed on the product side, you'll be okay. And I think that is it. Thank you for your time. I hope the rest of your break goes well, and I will see you soon.